Hello and welcome to my channel. On the 1st of December, the SAQ VLF transmitter in Sweden was doing a centenary transmission, 100 years since it was built, which is must have been in, when was that, 100 years ago, 1924 perhaps. And I thought I'd take a listen. It's down at 17.2 kilohertz, which is a very low radio frequency. It's just part of the audible spectrum for some people, or the top end of it. So I decided to have a listen, see if I could hear that signal, and I'll show you the equipment that I used, which was nothing very special at all. It's hard to receive signals at such low frequencies because you need extremely large antennas, and I was using a mini-whip antenna, which is I think 4 centimeters long, a PA0 RDT, which I'll show you. And using this, I was indeed able to receive some signal. Here's a look at the antenna. So this is the description of a PA0 RDT antenna from Roloff Becker in the Netherlands. And you can either build one yourself using this design, or you can buy one ready-made, which I did. I bought one directly from him. Actually, I bought 2 of them because I liked them. And you can guarantee that it's been properly constructed. There are some Chinese knockoff versions, which you can even buy on Amazon, which are way cheaper. I did get one and it didn't work at all. It was full of mistakes, so I just sent it back. So it consists of a low noise preamplifier, the probe. This is the small antenna, which is, I think it's about 40 millimeters long, and low noise amplifier, quite high gain. It might be about 50 dBs, which needs power fed up to it through the coax. And this is the board layout. So the antenna's that bit. It's 30 millimeters wide and 45 millimeters long, which is nothing compared to the wavelength at 17 kilohertz, but it actually works very well on VLF, as you'll see. This is the power feeder circuit, the bias T, which goes in the coax line and sends the 12 volt supply to the antenna. And they recommend, he recommends you mount it outside, play around with grounding to try and eliminate common mode interference, because it does pick up a lot of domestic interference. This is a breadboard construction of the antenna. So what it looks like when it's put together is this. It's in a piece of plastic drain pipe, which is waterproof, which I have outside on my balcony and fed with quite a lot of coax. And then there's the bias T in here. And the whole thing, I think, costs between 40 and 50 euros, which is quite an okay price for an antenna that really works, even though a lot of people knock it and say it can't possibly work because it's too small. Nevertheless, it does pick up signals really well on VLF. It's the best antenna I have for VLF. On HF, yeah, you can do better with a mobile whip or a long wire antenna, of course. It's about comparable with a loop antenna, perhaps. So that is the PA0 RDT antenna. Then we'll go on to have a look at the output of my receiver, and you'll see what signals I've been receiving. Before I show you what I received, I'll show you what they were transmitting. Here's a short video clip of the YouTube video stream from the SAQ transmitter in Sweden. And of course they're sending Morse code because it was 100 years ago, but you know what to listen for in my video afterwards. So that was the transmission from the very old style, almost like a turbine, 17 kilohertz generator. It looked like a medium-sized power station. On the receiving side, I was using an SDRPlay RSPDx receiver, SDR receiver, and the software was an SDRConsole, which is my favorite SDR receiver software, which runs only under Windows, which is a bit of a problem because I'm getting rid of Windows step by step, and I'm looking for ways of running it on Linux. There are, of course, plenty of other SDR programs to use, but that one's my favorite, and I don't really want to lose it. Anyway, let's have a look. You'll see I move the cursor around on the screen so you can see various settings that I've set, and I'm not talking over the video. And you'll have to listen carefully for the very weak CW signal down at 17.2 kilohertz, but it's in there. So that was my effort at receiving the 17 kilohertz signal, and it's prompted me to try and improve things, because they're going to do a Christmas broadcast on the 24th of December this year, and so I'm building a few new antennas to be able to pick that signal up a bit better than the miniwhip, hopefully. A large resonant loop antenna. I've ordered a lot of wire to wind up in a loop, as usual. And for the receiver, the SDRPlay is great, RSPDx, but I thought I'd play around with other receivers too. And one idea I got from the people who are listening to the Schumann resonance around the Earth down at 6 Hertz or 7 Hertz was to use an audio preamplifier and ADC, analog to digital converter. So I've got these ones, which are cheaper than buying a real SDR receiver. Sorry for the wobbles. So there are 2 of these with microphone XLR inputs connected to there's the bias T for the mini-whip antenna. There's a splitter, so I can split it off to various different receivers. There's another splitter, so there's plenty of loss in the signal path, but it seems to work fine. And then the analog to digital converters and USB connected to a laptop to be able to record the signal from an SDR receiver software, and it works really nicely. I use SDR++, which is SDRPP is its file name when you run it, and it works really well with the analog audio input like that. I'll show you that in a future video. Thanks for watching. Remember to like and subscribe, and see you in the next one.